As a chemical engineering student, the concepts within the general chemistry course is essential for us to further understand the upcoming requisites in our second year. Unfortunately for some students, general chemistry can be difficult to comprehend, especially when it comes to calculations, since you're bound to make mistakes with estimations and have room for discrepancy. Presenting the ThermoMatic, the Thermodynamics Wizard. It aims to assist students who weren't able to comprehend those concepts and help them process calculations faster and easier.
So in this part, we're going to show you how each and every function of the ThermoMatic calculator works. We're going to start it by running the code. The first function, which is the specific heat, we're going to press 1 to start the function and input the parameters such as the heat transfer, the mass, and the temperature change. And then we're going to press enter and the calculation appears. Our second function, which is the specific heat ratio, we're going to type 2 as it was our second function, and then we're going to put the specific parameters such as the heat capacity at a constant pressure and heat capacity at a constant volume. Then you're going to finish it with your calculations.
Entropy. This section refers to a measure of the disorder of a system. Entropy also describes how much energy is not available to do work. The shown code is the portion needed to run the set category of the thermodynamics calculator, equipped with several formulas given as a way to calculate entropy. As such, the following code utilizes functions. It also utilizes commands such as print in order to finalize and input the value when the user runs the system. The needed value for entropy are as follows. S, short for entropy, is equals to Q divided by temperature or T in Kelvin, with Q as heat transferred in joules, T as temperature in Celsius, and with T Kelvin as temperature in Celsius needed to be converted to Kelvin, as it is an essential unit and a must when getting the value of entropy. As mentioned, we would like to emphasize that conversions are also used in this segment, with Celsius converted as Kelvin as shown in this segment of the code in order for an accurate calculation of the value of entropy. Moving on to enthalpy. This section refers to the measurement of energy in a thermodynamic system. The quantity of enthalpy equals to the total content of a heat of a system, equivalent to the system's internal energy plus the product of volume and pressure. Just like entropy, the said portion also utilizes functions such as flow. The needed value for entropy are as follows. H, short for enthalpy, is equals to U added to the quotient of P and V, with U as internal energy in joules, with P as pressure in atmospheres, and with V as volume in cubic meters. It is also worth noting that conversions are also used in this segment, with atmosphere converted as pascals, as shown in this segment of the code in order for an accurate calculation of the value of enthalpy. Moving on to Gibbs free energy. Denoted as G, it combines enthalpy and entropy into a single value. Same as the other sections, Gibbs free energy utilizes functions. Based on its formula, it is simply the combination of two previous aspects, which is enthalpy and entropy. In order to get the value of Gibbs free energy in the calculator, the programmers used its original formula and applied it in the code. The formula for Gibbs free energy are as follows. G is equals to T Kelvin deducted to H and its value multiplied by S, with the variable H representing enthalpy in joules, E representing temperature in Celsius, and S representing entropy in joules or Kelvin. It is also worth noting that conversions are also used in the segment with Celsius converted as Kelvin as shown in this segment of the code in order for an accurate calculation of the value.
ThermoMatic also offers other features such as error handling, in which the program knows whether the inputted characters is valid or not, which is being showed in the video. ThermoMatic also offers other features such as the multiple calculations in a single run and an exit button, which is our function 6.
In conclusion, Python's versatility and application of various coding techniques are instrumental in creating powerful tools like ThermoMatic, the Thermodynamics Wizard. It is set to change how we use and understand thermodynamics, with its all-in-one function covering important measures like enthalpy, entropy, specific heat, heat capacity, and Gibbs free energy. It promises to make calculations easier and more accurate. This benefits students, professionals, teachers, and researchers in many fields, whether you're in chemical engineering, medicine, or in physics. ThermoMatic's easy-to-use interface and strong capabilities can help you learn, research, and improve processes. It's a tool that aims to drive innovation and progress by simplifying complex thermodynamic concepts and making them more accessible for everyone.